to you once again, my lovely students. We thank God for another blissful day the Lord has given us. So we continue with our studies on indices. We are still on indices. So the other time we talk about the laws of indices, right? And there were 9 laws. So we talk about them. So if you mix, or if you haven't watched that one, kindly go and watch indices. As I said in the syllables, the content are just 2. They are the laws of indices and solving equation involving indices. So we finished with the laws of indices in our first meeting. So this meeting will talk about solving equation involving indices. Solving equation involving indices. Okay, so that's what we'll do today, or that's what we'll do this morning. So please kindly subscribe to my YouTube channel for any updates or for any information. So kindly subscribe to Teacher Foster Media. That's my YouTube channel. Okay. So equation involving indices. They say there are equations which have the variables or the unknown quantity as an index or as exponent. So in equation, what it simply means is that the index or the power or the exponent is in equation form, right? We all know what equation means, right? So for instance, so a power 2x plus y equal to a power 4 or a exponent 4. So if you see something like this, it is called what? Exponential equation, right? Exponential equation. So to solve an exponential equation, you have to always make sure that the bases are the same. Please, I'm repeating again. To solve equation involving indices, you have to make sure that the bases are what? The same, right? So that's our topic. Solving equation involving what? Indices. Or you can also have so all of these are equation involving indices, right? So to solve them, as I said, you have to make sure that the bases are what? The same. Okay. So let's take notes. Please, in order to solve equation involving indices, the base, right? So the base, so note. Please take note of this point. It's very, very important. So to solve equation involving indices, the base should not be -1, 0, or 1. Right. So, and most of the time they will not give you the base to be -1, 0, or 1. So please take note. If the base is -1, -1 raised to the power anything will give you -1. 0 raised to the power anything will be undefined. And 1 raised to the power anything also give you what? 1. 1 raised to the power 1000 is 1. 1 raised to the power whatever is 1. So the base will not be -1, 0, or what? 1. So take note. Okay, so in solving equation involving indices, there are 3 forms of the equation that you may be given, right? So 3 forms. So the 3 forms, the first one is linear, then the second one is simultaneous equation or simultaneous equation, whichever way you say it is the same simultaneous equation. Then the other one is what? Quadratic equation. So in solving equation involving this, is either the equation will be linear, simultaneous, or what? Quadratic equation. So we have one linear, okay, so this what equation involving indices, it can take any of this form, the linear, the simultaneous, or what? The what? Quadratic equation. Right, and if you check through the WASI or the past questions, most of the time it's the linear. Then I've seen one simultaneous equation. There haven't been any quadratic equation. There have not been any form of quadratic equation in the WASI. WASI, the indices is just basic knowledge, so they don't stress too much, but because of you don't know what will come, so I'll just treat 1 or 2 questions involving quadratic so that when you see them somewhere, you can handle it, right? So these are the forms of equation involving indices may take, right? So it can either be linear, simultaneous, or quadratic. So when you see the question, you have to know whether it is what? Linear, simultaneous, or what? Quadratic. So let's start with the linear. So linear forms of the equation. So example 1. And we know linear equation. You know how linear equation looks like. So I won't worry myself talking about linear equation. So we have our equation 3 3 exponent x plus 1 equal to 81. 3 exponent x plus 1 equal to 81. So as I said earlier on, to solve equation involving indices, you have to make sure that the bases are what? The same. So we have 3 and 81. So how can we make 3, or how can we make 81 to be 3 exponent something? So that's what we learn about power or repetitive multiplication. So we'll use this 3 to check how many times will 3 multiply itself to give you 81. So if you can check from your calculator, 3 times 3 will be what? Times another 3, times another 3. So you can see that 3 will multiply itself 4 times to give you what? 81. So we can write 81 in the form. So here will be 3. So 3 will multiply itself 4 times will give you what? 81. So now our bases are the same. So when the bases are the same, you just equate the exponents or the powers or the index. So my base here is 3, here is 3. So I'll just equate the what? The exponent. Then I'll proceed to solve the linear equation. So I'm done with solving example 1. Right, so my final S will be what? 3. So if I bring 3 here to be what? 3 plus 1, which is 4, which is the same as 4 over here. So it means my answer is what? Right. Okay, so this is an example 1. Let's take another example. Okay, so let's look at the example 2. So here the base is 4. Here the base is 8. So how can we make the base to be the same? You know, if you could remember, I told you that indices came about or it was developed due to what? The concept of what? Repetitive addition, repetitive multiplication, sorry. Due to what? Repetitive multiplication. So what two numbers should we multiply so that one will give us 4, one will give us 8? Right. So if you check it, you see that 2 multiply 2 by itself, it will give you 4. Multiply 2 by itself 3 times, it will give you what? 8. So it means our base is what? 2. Please always remember to put the exponent in brackets so that it won't confuse you when you are expanding it. So this is how I do. So 2 times 2 to give you 4, which is this. 2 times 2 times 2 to give you 8, which is this. So this is my exponent. So it means that my basis is correct. Right. So now since the bases are the same, I can now what? Equate the exponents and move on what? To solve for my x. Right. So now I have 2 into bracket x plus 2 bracket close equal to 3 into bracket x minus 1. So I'll expand this linear equation and solve. I'll expand. So this one multiply this, I'll get 2x plus this one multiply this, I'll get 4 equals to this one multiply this, I'll get 3x. This one multiply this, I'll get negative 3. So I'll group like terms and solve. So I'll move this one to the other side of the equation, which will be negative. So my x is what? 7. Right, so this is an example 2 of the linear form of what? Equation. Right, this one are very simple. So let's take example 3 of the equation involving linear. So with this one, we are to find the value of y. Please, as I've been telling my students, the WASI this time, or in solving questions, they have realized that students are having challenge in solving equation involving fractions. So please take note of equations involving fractions very well. They know that students can't handle fractional problem, especially the WASI. So they like certain equation involving fractions in every aspect. They can get equation involving fractions. So please handle, anytime you see equation involving fractions, please be patient and take your time and solve it well, right? So let's see the solution for this question. So we remember negative index or reciprocal. So if it is fraction, we'll write it in what? Reciprocal form, or what? Negative index. So here will give us okay, so we have changed 1 over 27 to 27 exponent negative 1, right? So that's negative reciprocal or negative index, right? So now that we are able to write it in this form, then we will look for a common base for them and what? And proceed, right? So if we check 9 and 27, the base will be what? 3. 3 multiply itself twice will give you 9. 3 multiply itself 3 times will give you what? 27, right? So our base is what? 3. As well as I said, always put your exponent in brackets, right? Please, the reason why here is negative 3 is 3 times negative 1, you still get negative 3. Right, so 3 times negative 1 will give you negative 3. That's why I wrote negative 3 over here. So since my base are the same, I'll proceed to what? To equate the exponent and solve for the value of what? Y. So I will expand and what? Simplify. So if you multiply this by this, you get 3y. Multiply this by this, you get 3. Multiply 3 by this, you get negative 3y. Multiply negative 3 by negative 2, you get positive 6. So I'll now group like terms and simplify. So this negative 3 move to the other side of the equation, which will become positive. This positive 3 also move to the other side of the equation, and which becomes what? Negative. So my y becomes what? 1 over 2. Right, so you divide through, which will get what? 1 over 2. So please take note, anytime you are having a fraction, write it in a negative index form, then you proceed. Okay, so let's take last example involving the linear form. Let's take last example. So 16 exponent x equal to 0.125. 16 exponent x equal to 0.125. Right, so they can write it in this form. The question can also say it in this form. Right, so when you see it in this form, you change the decimals to fraction. Right, so I'll have to change 0.125 to what? To fraction. So to do that, I'll get this one will be 125 over 1000. You know, you have learned changing decimals to fraction. So if you know how to do it, you get 125 over 1000. Right. So this one, it can be simplified. You can divide by 125 and it will divide itself 1, it will divide itself 8. So here I'll get 16 exponent x equal to what? 1 over 8. So as I said, anytime you see this thing involving fraction, no, it's a negative index form. So you have to convert it to what? To negative index. So now I have 16x equal to what? 8 exponent negative what? 1. Okay, so let me continue. So I'm now coming to look for my common base. Right, so if you check 16 and 8, the common base will be 2. 2 multiply itself 4 will give you 16. 2 multiply itself 3 will give you what? 8. It is not 2 times 3, no. 2 multiply itself 3 times, not 2 times 3. So here I'll get 2 for x equal to 2. So as I said, always put your base, put your exponent in what? In brackets, so that it will confuse you. So since the base are the same, I'll just proceed for x. So if you multiply this by this, you get what? -3. So that's it. So please, we have looked at the linear forms of equation. Please take your time and go through. You understand? It's not anything difficult. If it is fraction, you write it in an index form, right? So please, as I said, most of the questions these days are involving fractions. So please, anytime anything involves fraction, take your time to understand what they are asking over there. Then you do justice to that, right? So we have finished with the linear form. Let's move on to the simultaneous form. So either it will be in fraction or what? Decimals. If it is decimal, you can just use your calculator to punch 0.125. Then you see it in a fractional form. Then you break it down and what? And solve it. Okay. So let's talk of the simultaneous equation form. Okay, so as you know, simultaneous equation is an equation which involves two unknown, which the two unknown are what? The same. So simultaneous equation is just two linear equations with two unknown, in which the unknown should be what? The same, right? So let's take an example. So this is my example 1. 8 exponent 4 minus x equal to 2 exponent 1 minus y. Then the other equation is 3 exponent x plus 1, then equal to 9 exponent negative y. So these are my two equations, which gives me what? The simultaneous equation. So to solve it, you simplify the first one to get your linear equation. You simplify the second one to get your linear equation. Then you solve it simultaneously or at the same time, right? So let's simplify the first one. So now I'll find a common base for them. So 8 to just be 2 times 2 times 2. So 2 multiply itself 3 times, right? So since the base are the same, I'll proceed to what? To equate the exponents, then I'll simplify. So this is the base. Okay. So this is the new equation that we have got. So let's simplify it. So this will multiply this, I'll get 12 minus, I'll get 3x equal to. So this multiply this, I'll get 12. This multiply this, I'll get negative 3. I'll keep this as it is. So I'll group like terms, right? So I'll move this one to the other side of the equation, which becomes negative. So to become positive over here, now I'll move this one to other side, which becomes what? Negative. So this is my equation 1. Y minus 3x equal to negative 11 becomes my what? Equation 1. So let's simplify the second one too. So here we have 3 exponents x plus 1 equal to 9 exponents negative y. So we'll look for our common base, then we proceed. So checking from this, our common base will be what? 3. Because 3 times 3 will give you what? 9. Okay. So since the base are the same, I'll pick my exponents and equate them. I'll simplify. So x plus y equal to negative, multiply 2 by negative y. You get what? Negative 2y. So I have to group like terms. So this becomes my equation 2. I'll move this one to the other side, which becomes what? Positive. Then I'll maintain it. Then I'll move the positive one to the other side of the equation sign, which becomes what? Negative. So I have my equation 2 to be what? 2x plus 1 equal to what? Negative 1. So let me solve the two what? Simultaneously. Right. Okay, so let's proceed over here. So please, in solving simultaneous equation, there are about 3 approaches to solve it. You can solve it either through substitution or elimination or by graphical method. But for me, I prefer the elimination because it's easy to work with. You know, maths, there are several approaches. To me, the easiest approach would be elimination. Right. So in using elimination, you have to make sure that when you add, one side will give you 0 so that you eliminate that variable. So for instance, if I want to use elimination in solving these two equations, I can either multiply my equation 1 by negative 2. Right. So here, if you multiply, you get negative 2y plus 6 equal to negative 22. Because the 11 is here, the 22 will be a big number, and I don't like that. So I prefer the easiest one. So in solving the easiest one, I can multiply my equation 2 by positive 3. Right? So if I multiply this, here I'll get 6. Here I'll get 3. Here I'll get negative 3. So that this one will not be a very big number for me. So I prefer using the what? The elimination. So I'll multiply my equation 2 by what? 3. So that here will be positive, here will be negative 3, here will be positive 3. It can cancel that, so that here will be what? 0. Then I'll work with the what? With the y. Right. Okay. So multiply equation 2 by what? 3. So you multiply it by 3, I'll get what? 6. So I'll get 6y plus 3x equal to negative what? 3. So this becomes my equation 3. So I'll now handle equation 3 and what? Equation 1. So I'll solve them simultaneously, so at the same time. So I'll just add them, right? So 6y plus y, I'll get what? 7y. Negative 3x plus positive 3x plus negative 3x, or positive 3x minus 3x, I'll get 0. So it means I've eliminated what? The x variable. Then I'll equal to negative 3 plus negative 11 to give me negative what? 14. Right? So I can proceed here. I'll divide through by what? 7. So my y becomes what? Negative 2. Right. So to solve for x, you substitute this negative 2 into any of the equations. And then I'll prefer working with this one since the numbers are small, right? So however I will see y, I'll put negative 2 there. So this time I'll get negative 4 plus x equal to negative 1. So x will be equal to negative 1 plus 4. This will move to the other side, which becomes what? Positive. So my x becomes what? 3. So therefore, x equal to 3 and y equal to negative 2. So I'm done with example 1. Right, so solving the simultaneous equation is not difficult. Just take your time, watch the video, follow step by step, you understand. Right, it's very simple, very, very simple. So maths is not difficult. You can do maths. Take your time, have time for yourself, and go through, you understand it. Right, so let's take another example involving the what? The equation in what? Simultaneous form. So let's take example 2. So this is the equation. 3 exponent x plus 1 equal to 27 exponent y minus 1 and 1 over 3 exponent 2x equal to 1 over 9 exponent what? Y plus 2. So these are the two forms of the equation. So we'll take the first one and simplify. We'll take the second one and what? Simplify. Then after that, we'll solve them what? Simultaneously, right? So let's start with the first one. So this one, you could check that the common base will be what? Will be 3. By now, you should know how the common base to be what? 3, right? As I said, always put the exponent in bracket form. Please, always put the exponent in what? In bracket form. So since the base are the same, I'll just equate the what? The exponent. So I'll simplify. Then I'll group like terms. So this becomes my what? Equation 1. X minus 3 equals to negative 4 becomes my what? Equation 1. So let me tackle the other one to get my equation 2. So as I said, anytime you see anything involving fraction in indices, they're talking about what? The negative index or what? Reciprocal. So I'll write this one in negative index form, which will be then after that, I'll pick a common base for them. So checking through, the base will be what? 3, right? The base will be 3. So here, 3 is here. So I'll just change this one to 3, right? So now since the base are the same, I'll equate the exponent and what? And solve. negative 2x. So negative 1 times 2, you get negative 2x, which is here. Then negative 2 into bracket y plus 3, which is here. So I will solve this one. So this one will be, we are continuing. This one will be so this one becomes my equation what? 2. After simplifying it, so here, we move this one to the other side, which will become is negative. So to become what? Positive 2y minus 2x equal to what? Negative 4. So this one becomes my equation what? 2. So, and this is my equation 1. So let me write my equation 1. So let me write them well. So my equation 1 is for x minus 3y equal to negative 4. And my equation 2 is negative 2x. We have to write them in order. So yeah, so this is my equation 1. This is my equation 2. So I will now solve them simultaneously. Right, I will solve them simultaneously, which is very easy. So this one, as I said, you just use the elimination method, which is very simple. So if you check this, right, if you multiply the equation 1 by 2, here will be positive 2x, here will be negative 2s, and it will cancel out. So this one is very, so anytime you have two simultaneous equations, check which one can you multiply so that you can eliminate one of them. We'll solve simultaneous equation today till but since this one it is not main simultaneous equation, the equations are very, very simple. So check which one can I eliminate. So if I multiply here by 2, equation 1, the whole of equation 1 by 2, here will be positive 2s. Positive 2s plus negative 2s will give me 0, so that I will eliminate what? The x and solve the rest, right? So multiply equation 1 by what? 2. Right, so I'll get 2x minus 6y equal to negative 8. So this one becomes my equation 3. And let me write my equation 2, negative 2x plus 2y equal to negative 4. So I'll add them. So here will give me 0. It will give me negative 4y equal to negative what? 12. If I owe you 8 cedis and I borrow another 8 cedis, it will be what? Negative 12. So I divide both sides by negative 4. So my y will be equal to what? Negative 1 over 12 over, which should be what? 3. So here now y is what? 3. So let me substitute this 3 into any of the equations to get my x. So I'll substitute it into equation what? 1. So whatever we see y in equation 1, I'll substitute what? 3 over there. So here to 3 times 3 give you negative 9. Move this one to the other side, it becomes positive. So x is equal to 5. So therefore, x equal to 5. and y equal to what? 3. So that's it. So I'm done with the example 2. Right. So it's very simple. Just take your time and for a step approach. This one we just simplify it. You have done it already. Here is fraction. I've taught you how to do it. Then if you get the simultaneous equation, you have to solve it. I prefer the elimination. The elimination, you have to make sure that either the x variable or the y variable becomes 0. By doing that, you can multiply. You check which one you can eliminate easily. Then you multiply by what number you have to multiply. Then you proceed. Then you simplify, right? So this is example 2. Okay. I think 2 examples will be okay. Check the time. So let's take another example. Now let's move to the third aspect. So there are several examples in your textbooks, in your Aquila, whatever textbook you are using. Please, there are several examples. Kindly go through them. If you have any challenge with any question, send me a message in the comment section or in our WhatsApp platform. So please, so that I address it for you. For time's sake, let's take the quadratic form. So as we know, quadratic equation, it is in the form ax squared plus bx plus c equal to 0, for which a should not be what? 0. So for this quadratic equation, so the equation will be in the form of what? Quadratic. Quadratic equation is very simple. Quadratic. Right? So in our equation, it should be in this form. Quadratic what? Form. Right? Okay, so let's take an example. Okay, so this is an example. So let's see how the quadratic will also be solved, right? Okay, so this one, whenever you are given a quadratic equation, you should write them in this form. You are looking to write this equation in this form so that you can let this one be something, then we proceed to solve. So 2x exponent 2x, we can write it as 2x all squared, because this one multiply this, which will give you what? 2x, which is the same as this, right? So minus 5 into bracket. So now we will let y equal to what? 2x. Let y equal to what? So whatever we see y, we'll substitute 2x. Whatever we see 2x, we'll write y over there. Right? So here have y squared minus 5y plus 4 equal to 0. Right? So this is our quadratic equation. So we'll solve them. So you solve a quadratic equation, you multiply the x squared component by the c. So here is 1. So 4 times 1 is what? 4. So all two numbers for which if I add, I'll get -5. If I multiply, I'll get 4. Is -1 and -4. If I multiply, I'll get +4. If I add, I'll get -5. So my factors are -1 and -4. Right, so let's group like terms. So I'll now pick the common factor out. So the common factor here will be what? Y. The common factor will be what? 4. I have 4. Y minus 1 as well. So y minus 4. Y equal to 0. So I have y minus. So my y equal to 4 or what? 1. But remember here I said y should be equal to what? 2x. So I have not finished. So whatever I will see y, I'll write my 2x because in the equation they say we should solve for the value for x, not y. So whatever I will see y, I'll write 4 over there. Right, so let me substitute it over here. So instead of y, I now have 4 equal to 2 exponent x. So this one, the base will be 2. So 2 squared. So my x equal to what? 2. Then with y, you do for y equal to 1, 2. So 2x equal to what? 1. And we know that any non-zero number raised to the power 0 is 1. So instead of 1, I'll write 2 exponent 0. So here my x will give me what? 0. So therefore, x equal to what? 0 and what? 2. So I'm done with the quadratic form. So please, it's very simple. Try several examples in your textbook. If you have any challenge, chat me on the comment section or WhatsApp me. So the trick is you have to write any of them in this form. Most in the question you see it something exponent something. So your target is to write it in that form, and you will have to manipulate it to get something like that. Then we proceed to solve, right? Due to time factor, will not be taken back, but I will drop other examples in the quadratic form in our subsequent lessons, right? So please, the quadratic form, right? It's very simple and very easy to understand. So let me give you some assignments. Please solve them, and when you are coming to school, solve them on official paper. There are 10 assignments, so kindly take your time, write them, go through, take your time, solve all of them, and when you are returning to school, you submit. Please, I will take it on our first meeting. So solve it and bring it to me. I will use it to assess you As I said, I will teach this topic again. So please take it very serious. So let's take our assignment. There are 10 simple questions. You solve them and you submit it to me. And in the WASI, there have not been any question involving the quadratic, so don't worry yourself much about the quadratic. And learn more about the linear and what? The simultaneous, especially the one involving what? Fractions. So let's take our assignment. So you have to solve the variables in the given equation. So question 1. So the question 2 is simultaneous. Right, so you solve for the value for x and the value for what? For y. Where is 2x squared? 2x squared. this A, not 9, this A. So these are 10 simple questions. Please do them in an official sheet so that when we resume, you submit it. So thank you for your time. Please take your time and go through what we have learned today. It's very simple. Take your time and go through. You will understand it. Enjoy your studies. Bye bye.